So first of all, I'd like to get a feel from the audience. How many of you have heard of NNMI? Excellent. So that's a lot higher percentage than I normally get at conferences that I ask this question at. So the NNMI is the National Network of Manufacturing Innovation Institutes. It's an initiative started by President Obama back in 2012. There are now 8 of these institutes that have been stood up. Another one to be announced very shortly. It's very exciting. The federal government is putting up over $500 million so far, matched by industry, academia, and local state government, more than 2 to 1. So altogether, over $1.5 billion is being spent towards advancing manufacturing in the United States across a range of topics. So the institute that I'm involved with is in Chicago. We're called the Digital Manufacturing Design Innovation Institute, not to be confused with the Additive Manufacturing Institute that's located in Youngstown, Ohio. As my friend from Penn State mentioned, they're involved with both of those institutes, probably a couple of other ones as well. So I'm going to talk a little bit more about my institute specifically. So I always like to start off by explaining where the other institutes are located. I'm going to go through that very, very quickly. You can see there's the Photonics Institute up in upstate New York, the Lightweight Modern Metals Institute called LIFT in Detroit. There's one, as I mentioned, in Youngstown, Ohio, focused on additive manufacturing. Raleigh, North Carolina, focused on smart power. There's one down in Tennessee focused on advanced composites, one out in San Jose, California, focused on flexible hybrid electronics. And there's one to be announced here fairly soon, focused on clean energy and energy efficiency. But the most recent one that was just announced a few weeks ago is at MIT, focused on revolutionary fibers and textiles. You can find out a lot more about all these institutes if you simply go to www.manufacturing.gov. So my institute was awarded in February 2014. It's a public-private partnership. All the institutes are public-private partnerships, so it's not a grant. It's not a contract from the government. It's a cooperative agreement that the government enters into with a not-for-profit organization. So it's a 5-year cooperative agreement. In our case, $70 million from the federal government. It ranges anywhere from 70 up to 110, I believe is the highest one so far. And our institute has a team of companies, universities, state and local government that match the $70 million with $105 million is the guarantee commitment we have, which we will exceed over the 5-year period. So I'd like to level set just for a second because the term digital manufacturing is used by a lot of people and it means a lot of different things to different people. So for example, a lot of people hear the term digital manufacturing and they think 3D printing. So it's okay to think of 3D printing as part of digital manufacturing. I think that a more definitive term for that is direct digital manufacturing, the concept of being able to push that button and the 3D model that you have on your computer screen goes right to that 3D printer. There's no intermediate step. It's really cool. But here's a classic definition of digital manufacturing, and let me try to explain it this way. If you can imagine looking at a virtual representation of a product in a 3D CAD system, like my friend here from Autodesk offers, so you can turn that product all around and look at it on the computer screen. You've got an entire virtual representation of that product. Think about another computer screen right beside that one that has a complete virtual representation of the entire manufacturing process. So as the designer is making decisions on features, material selection, immediately the impact to time to market, cost to produce, amount of energy to produce could be on that second computer screen. So they know what variables they can adjust in order to achieve the outcome that their customer wants. So an entire virtual representation of that complete manufacturing process is a classic definition of digital manufacturing, and that's mostly what we're focused on in our institute. Link between design and fabrication. Both of the previous speakers talked about that. We too would like to be able to have the bits and bytes, the zeros and ones that make up that virtual product representation on that computer screen, flow seamlessly through the entire manufacturing process, up and down the entire supply chain. So having the machines that are involved in making, whether they're 3D printers or whether they're classic subtractive manufacturing like lathes, milling machines, etc., we want that data flowing directly to those machine tools from the computer systems. Eliminating some of these intermediate steps that take place today by printing off drawings and developing process sheets, all of this being able to go directly to the manufacturing process itself. The transparency into the supplier factories is something that the large OEMs are looking for. So hooking up machine tools to the internet, for the customers that are buying components to know exactly where their parts are in the process, especially if there's a hiccup. A lot of times companies that have a hiccup don't always call their customer right away and tell them. But the customers want to know that, and so they can make adjustments with other suppliers. So the data aggregation, analysis, action across the entire product life cycle. Think about what you can do if you have a lot of data from manufacturing, specifically machine tools I have in mind, data streaming to the cloud, and some really smart people analyzing and trending that data and doing predictive analytics, being able to predict when a bearing might fail so that you can replace that bearing on an off shift like the weekend instead of right in the middle of first shift production where it's going to cost you the most. So predictive analytics, predictive maintenance is a big area that we're doing research in. And technology transition to the small, medium enterprises is something that all the institutes have as a requirement. It's great to do these research projects and take the technology readiness level of each of these technologies from TRL 1 through 3 up through 4 through 7. But if we don't get these technologies transitioned to small, medium enterprises, we've failed. So every institute has that same requirement. DMDII has a similar structure as most of the institutes. We have different tier levels for industry, different tier levels for academic members. So you can come in at any level you want. We made our membership for small, medium enterprises extremely affordable. It's only $500 a year. So we have over 200 members so far after 2 years, and we keep growing literally every week. Our current membership portfolio, you can see some of the big names up there for some of the large companies like Siemens, Lockheed Martin, General Electric, Dow, Procter & Gamble, et cetera. We've got over 40 academic institutions now as members and lots of small, medium companies, over 150 together. So we continue to grow, and it's pretty exciting. We've got over $40 million worth of research projects now well underway. Our facility out in downtown Chicago is on a body of land called Goose Island. You can see in the top right-hand picture how the river splits and goes around this small body of land. So we've got 94,000 square feet that we've leased from an existing facility there. A lot of it's for collaboration because as these research projects, they all involve multiple companies from different teams. It's easy to come into our facility for those teams and do work together collaboratively. Sometimes it's difficult to do that inside of one company. So we intentionally have a lot of open collaboration space. We've got a beautiful manufacturing lab where you can come in and use the machines. You can demonstrate some of these technologies in these projects. And we've got extra room for future expansion as well. We had our groundbreaking on 30 October of 2014, and we moved in 11 May. So we've been in the facility now for about 1 year. I invite all of you to come, if you ever get a chance to come to Chicago, please come and see the Institute. We have approximately 1,000 to 1,500 visitors per month. So lots of people are interested in seeing what's going on. Here's a couple of pictures of the way it ended up. That's the front of our entrance there and inside the collaboration space I mentioned. And I also wanted to put a plug in for cybersecurity because when you think about digital manufacturing, as my friend on my right here just mentioned, the one professor at Irvine is looking at how they can stop people from stealing designs just by listening to the sound of the 3D printers. There's all kinds of ways for people to hack into machine tools. And we continue to talk about hooking up machine tools to the internet. Everyone's a little concerned about what's going to happen when I hook my machine tools up to the internet. Who's going to come in and do something to my machine tool and cause it to do something that I don't want it to do? So it's more than just simply stealing the design. It's causing machine tools to do things you don't want them to do. So cybersecurity is a very, very important topic. There's a lot going on in cybersecurity research for IT, very little going on for OT. So anyone that has any influence on helping DoD and DOC and DOE decide on what the next two topics are for the 6 institutes they're going to launch this year, put a plug in for cybersecurity for advanced manufacturing. That's all I have. Thank you.